Hello, AQA target clearers, my dear little programmers. Today, backed by popular demand, no, but task 19 from Zigzag is chunky, and I like it. I don't know how realistic it is for even a 16 mark or whatever you get at the end of the electronic answer document, but it's worth doing. So the brief is to have a helping function that will try all of the possible combinations of numbers allowed and operators, see whether they evaluate a target, and suggest them to the user. We don't want to duplicate a target, don't duplicate expressions that identify a target, and this not to be by default, but we prompt the user if they would like to receive suggestions. What's good about this is that this barely touches play game. That's at 19? Was it 19B? Because I think I may have tried it before. It barely touches play game, right? The only thing we need to do... Oh yes, I did just try it a minute ago, didn't I? Oops. Hey. Right, the only thing we need to do in play game here is this. Expression or help. And then if user input as an uppercase string, not even going to test the whole string, I'm going to test the first one, and if that's equal to capital H, we are going to call generate evaluation with it. Generate evaluations, yes. Okay. Generate evaluations. Bracket. Now, we're going to want to have, obviously, pass the targets and the numbers allowed, but that's it, because generate evaluation itself will do the printing. I might put numbers allowed. I will put a little print here to get a little screen space there. And so now everything happens in this new function, def generate evaluations. Text targets and the numbers allowed. No surprise there. So here in generate evaluation, we want to... I'm going to do it in two passes. I'm going to build a list of expression. So I'm going to want to initialize an empty list for expressions. And then I'm going to attempt... There's a thing there, so I'm going to wrap this in a try except, so just so that we skip if it deals an error, because division might get like annoying. But I think we should mostly be good, unless you try to divide by 0, which, because we don't support brackets, I don't think is possible. But still, when in doubt, there's no worry. Like if you can't evaluate one of the tried expression, you just move on to the next one. There's going to be a lot. It's combinatory calculus. So we attempt, and then if it works, and we haven't clear, clear, I suppose, find an expression, and this target hasn't already been matched. Print it, which means that we gonna have to, not tried. We want a list of match targets to which we're going to add as we find stuff that works. But like the list of expressions, right? This is where the stuff that's fun. So for, I'm going to use actual iterators because I want, for reasons they're going to be clear in a second. So for I in range of the length of the len of numbers allowed. Okay, first number. So at the top of this, I will want to have... No, I don't want... Actually, so I don't need... I'm not doing this anymore. That's why it's a second attempt, because I messed it up. Yeah, it's going to be easy to mess up. I thought I was improving it, but I wasn't. So for the first number, we're just going to call it A, out of complete lack of imagination. And A is equal to numbers allowed at index I. So far, so good, right? And then I will want to make a list, so I want to go like, let's call them num 4, because there's 4 numbers left, right? So I want to make a list of numbers, that's all the numbers allowed, without a. So to do this, I can show you in Python. If I've got the list 1, 2, 3, maybe with brackets, works better. If I do this and I say L at index, say 1, that's going to be number 2. And if I want to rebuild this list without this one, I just go everything up to index 1. That gives me everything up to but not including. And because index 1 onwards, with the colon on the other side, that's going to include that one. I will want to have L at, in that instance, 1 plus 1 onward. The good news is if I do, so this is 0, 1, 2, right? If I'm at the last element, it will actually just give me nothing. That's helpful. So if I then, if I do L colon 1 plus L1, 1 plus 1 is a bit daft, but here we are. Onwards, that's the list without the element I've selected. So it's colon I or colon index, and then L index plus 1 onwards, index plus 1 colon. So my num4 is numbers allowed up until I, up until but not including, and the numbers allowed plus from plus concatenates lists, obviously. So I stick that along with I plus 1 colon to the end. So I'm only going to pick my second number from the rest of them. The reason I can't do it like on the stream, because on the stream I was like, oh, you just iterate over the whole list, and if it's the same number, skip it. But in the training game we get 2 2s, and those 2 2s you should be allowed to replicate because they're 2 different numbers. So you need to physically remove whatever, find, it's by index rather than by value, because you might have duplicate values, but the index will be unique. So you don't really want duplicate numbers, because if you are given duplicate numbers, you can use duplicate numbers. You don't want duplicate indices in numbers allowed. Right, so that's my num4, but let's not forget the operator, right? So for this one is simpler. Oh, let's call it O1, because I don't want to start mixing up all of the variables. For one, another thing I'm going to is a list of operators. And do I have this on my... Yeah, it's old friend, this one, as strings. Now for O1 in operators, so we've got O1. This one we don't need to say O1 equals, right? We got O1, and then that's first up. Now we need the second number, so we're going to do for J in range of num4. No, length of num4. Forgive me, num4. For each of those, we do B is equal to, let's be systematic, second num, B becomes equal to num4, so number, like there's 4 numbers remaining at index J, and I have a num5 that is num4 up until, but not including index J, plus num4 from J plus 1 to the end, to the very bitter end. But before I do this though, because at this stage I have A, I have O1, and I have B. So I'm gonna append this, make a little list of this. That's my list. That's the... So this, if I'd stopped there, right, this will generate 5 possible A's, then 4 of this, so there's already 20 ways in that, times 4, there's like 80 times this kind of like 2 numbers, 1 operator expression. So let's append this to expressions. But I got a little problem here, right? Because, well, not a little problem, but I need to think ahead, right? Because those are numbers. Numbers allowed contains numbers, which sounds stupid, but right? Was O1 is a string. So out of consistency, I'm going to want everything as a string. So I've not even finished my attempt, exclamation mark, because attempt to evaluate them using the stuff that comes in the code. So we're going to simulate our generated expression being a user input. So it's like using user input. It doesn't do it to complete for comments, obviously, in RPA. and, or like convert to RPN, I think it's called, using convert to true RPN, and evaluate, in one word, evaluate RPN. So convert to RPN takes the infix expression as a string without spaces. So we want to generate a string without spaces. So I'm building an expression as a list of 3 strings, which is already kind of good. I'm already kind of halfway there. So we get num5, and now we're going to start generating, we tack another operator there, so that's O2. This one doesn't change, don't need to do a copy of the list. We're always working, you can duplicate operators, like kind of this plus this plus this plus that. For each of those, we don't need to do anything there. I go straight to, well, I'm going to write second up, and go straight to, for K is the next letter in range len num5. No, I tripped myself there. I'm talking about the remaining number of numbers, the remaining count, the remaining size, the size of the list, right? There's the size of the number of remaining numbers. I can't explain what I need to say without saying numbers twice, I'm sorry. So for this operator going all over my new list that now only contains 3 numbers, I am at the third one, right? That C is equal to num3 at index K. Cool. So from here I can build a what you may call it, expression. So expression, sorry, I'm not completely here today. Append. Right, that's better. This one I'm gonna copy. It's kind of not. And then O2 and str of C. Cool. Finally, num2 becomes equal to num2 becomes equal to num3 up until K plus num3 from K plus lowercase k plus 1 colon. And sorry, that's the third number, yeah, second number. And there we go again. For O3 we're nearly done. Well, of sort, right? Because with the third operators we can have up until 4. Yeah, so it's the penultimate operators in up. I shouldn't have. Okay, this is now the third up. Nothing to be done here. I'm going straight into the loop for GKL in range len num2 colon D is the, so that's the 4th number here, 4th num, and that's D, and it is equal to num2 at index L. It's like we're just doing the same thing all the time. It's just that like the letters and numbers change slightly every time, and if you mix it up, you can run it forever. Well, not forever, but run it in a way. It's going to be very hard to detect because you're using a correct variable name, but it's not the one that should be here. And because that code is basically fractal almost, because it's self-similar at different scales, it's going to be a nightmare. So in situations of stress, we don't want to be, doing this. Is probably why they won't set it to you, but who knows. All right, so I have O2 and str of D. Cool, that's looking sound, and I'm nearly there. I need the 4th up. No, I need to take a num1, so that's just num, right, because it's the last num. Now I don't know. I'm gonna have to make it a list. Because I don't know whether it's before or after the thing at index L, so I don't know where to pick, how to fetch it from, whichever one is not D, and I can't do it by value as we've established. Num3 L plus 1 colon, all good. Now I don't really need to use a, no, I do need a 4 because there's the 4th operator, right? So for the O4 in operators, so each 4 number expression can only generate, as it were, one, there's only one, because there's one remaining number, but there's like actually 4 possible 5 number expression from each 4 number expression because of the 4 operators. For operators, this is why I don't do anything. I'm just gonna say E, my 5th number, straight to whatever's at the top of num, because there's only one element, right, at this stage. So we get a 4, we get E, and we just need to append this. Cool. Now, let's just check for anything red. That's looking pretty good. Right, so because I have this, and it's all of the stuff I want is really in here, I'm going to see if I can just create Python, debug Python, from ZZ19B, import generate evaluations, and that worked. So I now call generate evaluation with the empty list because I'm not worrying about targets yet, but let's say 1, 2, 3, 4, 5. But this is going to do nothing, sorry, obviously. So here I'm going to print expressions, save it. So every time I change the file, I'm afraid I need to kind of bail out of Python completely, then re-import it, and then do that again. All right, up. Oh, okay, well, look at this. That's a lot of it. Well, the printing is what's taking a lot of time here. Remember, like, at the point at which you're seeing the stuff scroll by, it's printing the list. So, like, the slowness of it is the slowness of printing. Those have all been generated. But I don't know what you can see, but we'll see that the length should be 5 times. I mean, that looks, that's a 1, 2, 3, 4 expression. And then it backtracked to 1, 2, 3 expression. That doesn't look right. 5 and 4 star divide 1. Divide 1. They shouldn't be. Okay. What if? Let's return expressions, and like we can inspect it a little bit further in Python console. E is equal to this. So boom, there, right? That's how quick it takes. And E0, fair enough, as expected. E1, that's right, because we go straight from the 2 plus the 3 plus the 4. So if I do E, yeah, I mean, okay. So how about 4? E in no, because that's E already, right? For in E print. Expert. This is going to be like, oops, yeah, I need to do it, of course. Just because it's in the console doesn't mean you can't not indent. Right, so you'll see that it kind of starts and it backtracks. 5 divide 4, 3, 2, 1, 5, 3, 5, 3, 1. I feel like it's not doing, it's oh yes, sorry, this is what I've messed up. I've just copied it without adding the last one. So 3. Oh no, I've even not copied. Okay, what am I? This should be 03. That's the problem. That's the problem already, right? And then this should be 03. That's why I'm not copying it and typing it from scratch every time. It's a guarantee that I'm not messing it up, because that's why I wasn't copying and pasting the others, right? And string E as a string. Okay, I'm now much more at peace with this code, which is important. Okay. Yeah, that's more what I expected to look like. I mean, not I can recognize those things straight away, but like towards the end, we've got like 5-digit ones that are all built from the 4-digit ones by changing the number. I think if I do it again with printing line by line, we'll see them kind of starting with the 2s, then all of the 3s derive, all of the 3s and all of the 4s, and 5 derives from this, then backtracking the 4, the 5, the 4, the 5, and then sometimes backtracking up to that kind of another set of. I'm assuming everyone understands the term backtracking, because that's kind of how you explore graphs and trees and depth first and breadth first algorithm. Yeah, we get all of the last 4, and it was just the last one we did by picking 5, so we started with 4, 3, 2, 1. Yeah, because we'll do them in order. Once we've picked the one, we'll do them in order. Okay, I'm happy with this. Like we have successfully generated all of the stem expressions. Now, they are stored as lists of strings, so we're going to join them. So let's do the attempt to evaluate them. Okay, for exp in expr, expr becomes equal to, we're going to make a string out of this, right? So it's like empty string.join, and you pass the list. This is going to turn this into stuck together string. And then try convert to RPN expr, and then result evaluate RPN exp of RPN. Right, okay, so we've got the thing that may do nothing on accept, but that way if there's a problem in here, we don't have to worry about this. We might, at worst we might miss a hint, but I doubt it, because if it was a legit hint, it should be something you could pass as, the user can input. So that now at this stage we have a result. So if result is larger than 0, and we're also going to check it's an int. So so why you could do int result equal result. The way they do it, they use floor. So here they check that because this is where it evaluates, right, division and so on. This is an evaluate RPN. So this is where they will divide, and divide might end up with a result that is not an integer. So that's like if. So S0 is like the kind of result of the thing, because you just appended it, which that's the end of it as well, because it's at the end of the while, right? So like the final thing, that you only end up with one thing on the stack, and that's one thing on the stack, and that's the result. So if the result that's at the top of the stack, the evaluation stack, minus the result cast to a float, that's already cast to a float, but whatever, minus the floor of this, meaning if it's a decimal number, you just take the round number below it. So if there's no difference between it and the truncated number, then it's a valid integer, you return it. You could have casted this to an int, by the way, but whatever. Otherwise, you return -1 as an evaluation failed. So we're going to use this, except instead of S0 and casting it to a float, I reckon I might cast it to a float, because if they do it, why not do it? I just don't want to waste some time figuring out why I've introduced a bug deliberately in my own code, which is kind of most of what programming is. So it's not S0 here, instead it's result. So if we've got this and we've got that, right? And yeah, sorry, we need this, we kind of need this here. I'm not gonna continue with Copilot. I thought it's on everything on, because I run out of free requests. Like 2 days before my assignment in R was, assignment was due. I chose to do it in R and teach myself R with Copilot, which, yeah, that's fine. I had to copy and paste. I have to actual LLM in the browser. But by the end, whatever, it's not the point here. Okay, so our result needs to be positive. It needs to be an integer, and we need to not have matched it before. And so that's what we're basically doing this, right? If it works, if it evaluates. Ooh, sorry, and shoot. I'm gonna do it in bits, you know what? Okay, so this is like checking, basic sanity checking, right? So this is like vaguely valid result. Potentially valid. And then if result in targets and result not in matched targets, right? So if it's in the targets and we've not matched it before, then we are going to print. I've got expr, yes, excellent. So we're going to print expr equal result. which this is what we're doing. So we are doing this here. And I mean, it looks ugly as, right? And it's about 106 minus 57. That's like 51 lines of code, which is like, it's a, I don't think you'd be legitimately asked to write 51 lines of code even in a question. It'd be interesting to see actually like the sort of mark per line. Although Python's more pithy, we could mark per line in the recommended mark scheme, the example given mark scheme. I think we kind of ready to rock and roll and test. Save it, close it, run it. Oh no, I can't run it without quitting Python. And now I can run it. Help! Ooh, for explain expressions. Yeah, I should always look at the wiggles. You'll save yourself kind of run it and then fail, and you know, especially if you run things in debug expressions. Yeah, okay, clear. And again, yes, okay, fine, but help works just as well. Wow, okay, that's a lot of them. I feel like we're matching the same one more than once. Oh yes, of course, because I'm not. When I match something, I need to add it. Yeah, okay, yeah, very good. Match it target, append result. You would have corrected and noticed my mistake before I did. Cool. Again. Surely it's going to find, yeah, the old 512. Yeah, well, I wouldn't have worded like usually we do it kind of the other way around. 512 divided plus 2, etc. I didn't know you could do 75 here. That's killer. It penalizes, of course, because you kind of waste the loop of the. Could have put all of this in an else. Well, it's coming is fair. If you ask for help, you get a -1. So that works, right? So I can maybe well, it doesn't really matter. The training game is boring because they always give you back the same numbers. Let's have a look at the diff. So right, select the compare and ZZ19B. Compare is selected. So in this one, to solve the problem of the autosolver that trusts everything, barely touch play game. That's the beauty of this. We're just asking, do you want some help? And if you do want some help, then we go straight to generating the help. The help is threefold. We generate the expression by building them bit by bit. When I say build them, what we do is we kind of like set a number of variables, and then the stuff we add, those are all of the expression append, we pass them as lists. Now it's a list where the numbers are already as strings, and so those are all of the 2 expressions, and then all of the 3 number expression, all of the 4, and all of the 5, or the 1 5, or the 4 5s that are possible to make from the previous 4, and we build them up on top of each other. And then we need to see whether they work. So we keep track of the match target and empty list for each of those. This is kind of like explaining a bit, right? We get those as a list of strings. The operators are already strings. So we take those and join those individual strings as one string with no delimiters. So that comes up as an expression, you know, as we input them without spaces in fixed expression. We convert and evaluate inside a try except, although no, yeah, let's definitely, right? I just don't want to mess with it. Probably could try it without it, but you know, when in doubt. And then we check first that we have a positive result and an integer one, and then we check if it's a target matched and a target that's not already been matched, and if with that we print it. We don't forget, like I did, to add it to the match targets, and that's your Zigzag Task 19, the autosolver that tries absolutely everything. Thank you for watching, and I'll see you soon on the live stream. And it's still like what, like it's the 22nd, so that's like we're kind of like less than 4 weeks. Just 1, 2, 3, less than 3 weeks to paper 1 of AQA. Well, of the computer science for everyone, but for AQA it's on computer. Happy coding.